Do I get it that you take care of the slides and everything?
You do everything.
I do everything. Okay, please show me.
You're going to, it's going to pop up here.
Okay.
And you just an iPad. You're going to,
Okay.
and if
So that's where we are. Anyway, I'm heading the US part of a Norwegian company called Prox Dynamics. Prox Dynamics is a small company who set out some years ago to produce what we at that time called the smallest operational UAV for operational purposes, for military and for law enforcement. And just to take away all questions and magic in the beginning, this is what we are talking about, the Black Hornet as it is today. I'll come back to, of course, some details on this as we move towards the orientation. So let's see if we can get things moving here. Is it okay?
Yeah.
Okay. Let's move on. And now we just hope that technology is playing with us here. No, not that. That. Excuse me? Oh, okay. Sorry about that, ladies and gentlemen. No, I shouldn't say sorry because they had it under control. So anyway, it's just a small animation which shows the basic features of the system. So I want to just to play that. It's a short one so that you get some of the basics with you. The system, as I alluded to, was developed a couple of years ago, and this is of course a continuum, so we are always looking forward. But the present model we have has been flying operationally now for several years among Allied troops in Afghanistan and in other theaters. As of today, I think from a company perspective, we have been selling the system to a little bit above over 15 nations or their military and or security forces. So it is in our perspective, a well-established capability. And I started to say we wanted to create the smallest operational UAV. We like to call it a nano UAV. One can, of course, discuss whether it is nanotechnology per se, but we wanted also to distinguish it very clearly from the class of micro drones we know, which can be in this size, weigh several kilos, and fly at 50 miles an hour. That's why we have chosen to call it a nano UAV. It is, as we all know, an extremely, let's say, a very advanced ISR capability, and it is meant for we designed it for the team, the squad, and the single SOF operator, really at the lowest level of any organization. That is the background, let's say a little bit about the backdrop for it. So, yeah, I could of course pull a few Norwegian jokes now and ask you if you had been drinking Akivit and suffered hell the next morning, etc., etc. I'm very grateful for the slide, but that means that you skipped the video, gentlemen. So that's okay with me. We'll see if we can make it going again. What you see on the screen now? Okay, okay, I'm all yours. The system overview, as you see here now, I'm not going into every single part and line you see there, but you see on the top there the whole system as it is, 1.3 kilos, less than 3 pounds. Weight has been one of the most important factors here. As we sometimes, with a little bit of a smile, say, if infantryman number 1 would carry all the good projects and suggestions from the industry and some other people, his average weight would probably have been 2 tons and he wouldn't move 1 millimeter. So for those guys who are out there and carrying the fight, every gram, every ounce is important for them. As you now see on top there, you see one unit. It is a base station there. It is a 7-inch screen, and there are 2 sensors or helicopters. That is what we would call a basic system setup. And you see the different functions in the base station there. What is important is that the base station is the recharging station for the birds. It is the main battery. It is the main processor. The controller is a very, very simple thing, and that is a part of the, let's say, what is so special about this? One of the special things is it is very, very intuitive and simple for the operator. What you should have seen now on the lower end there is, I call it the stash, all the bags and the Pelican cases, and that depends, of course, on the customer, what they would like to have. So, double tap. Let's see now. Tap here. Come here now. Have a look. I tapped twice, and this showed up.
Okay, so, and let's see.
I'm going to smile to the camera here now, trying to keep it up. Okay, here we go. Here you see a couple of the key features. Very simple hand control, 18 grams weight. It's an extremely light sensor, silent. It can operate very covertly, has 3 cameras in the day version, a range of 1 mile, endurance up to 25 minutes. There is a night version with thermal image cameras, wind up to 15 knots, 20 knots gusts, and it's basically a very, very easy system to handle. Those are what I would define as the main features. Now, with a little bit help of you gentlemen, can I get back to the presentation again? Miracles do still happen. Okay, anyway, let's move on. I'll take the next slide for you. I thought I could. If you look at this one now, it takes the most important factors I've been partly touching. I'm just going to allude to a couple of it. We talked about the weight, the helicopters, we mentioned them, the 2-way digital radio link, a proprietary developed radio link, and it's one two-way link, digital, which takes care of both the continuous feed of information from the cameras and the necessary navigation and guidance information. Range 1.5 kilometers. One of my good friends and colleagues from Norway standing behind you here, he's flown the system out to 4,000 meters. And we had to test it here some time ago, and I went to Pikes Peak and I took it up on 12,000 feet. It was a nice flying experience, but it is important that these systems also have the capability in operating. For instance, when we fly in Afghanistan, you easily start on 6, 7, 8,000 feet before you get into an operation. Flight time up to 25 minutes, which gives you, with a speed of 5 meters per second, which gives you ample time in the target area. As we call it here, benefits, low visual and noise profile. Technically, it has a noise level of 40 decibels, 10, 15 meters away. And 40 decibels, in layman's language, I would say normal people do not recognize that it is around when it is 15, 20 meters away from you due to background noise. And the combination of size, the way it flies, and noise level makes it very difficult to be aware of unless you are seeking it and looking for it. As I mentioned here, it's easy to operate for a non-specialist. This is not the system for a pilot with his 80 hours training course, certification, etc., etc. This is for one member of the team, or even the single lady or gentleman who needs to have this capability. If one of you, ladies and gentlemen, were the selected operator in your unit, I would basically ask for a day or two. I will come back to it on one of my slides, but I just want to make a point of it because it's very different from the typical UAS thinking with pilots, aviation regulations, etc. Couple of things in addition worth mentioning. As you see here now, you see the size of it, how big or how small it is, but it still has it has servos, it has swash plates, it has everything a classic helicopter has. So once again, extremely advanced technology, but very simple and intuitive for the operator. The power source is I've mentioned that before, and you see also here about signature. So it is a fine-tuned ISR capability for that level. Here you see an example of what it creates. First of all, it creates motion imagery, i.e. real-time video down to the operator. That is a low-resolution imagery with a 2x focus capability. So that when you are flying, let's say for navigational purposes and general surveillance, you use your cameras, your video cameras, and then when you come closer to a target, you would like to take pictures, still pictures, snapshots in high definition quality, and you have 4x zoom capability in those pictures. From the moment you initialize a system, all the metadata and everything is going back in real time to the base station. Everything can be transferred to other means of communication or to other, let's say, be it a computer or a tablet afterwards for further assessment. But everything is stored in the base station. There is no actionable information in the bird. So should the bird crash out there, it would be totally useless in a short perspective. Of course, somebody could pick it up and gloom over it for the next years in a lab, but there are no tactical information of interest in the bird there. Yeah. These examples of snapshots gives you a small impression of what can we see from various distances here. Everybody understands the sensors are extremely small here, and the whole principle is go low, go close, and then you can basically get the same or much better than a high-flying drone up there. The other thing related to that, which is important to realize, is this one doesn't have any problems operating at this altitude, a couple of feet over the ground. So you could take it all the way down, and you can fly it up to the entry of a barn, look in the door, and you can say, yes, it's the green Honda we've been looking for. Match, and you have identification there. So you don't have to loiter all the way up there. You go there and you go around the corners. Needless to say, we have been in a lot of situations where we have been giving demos and operational support in various mount facilities for not only special forces, but in urban scenarios, down the street, over the building, around, etc. And you see now 30 to 20 meters, and you see 15 to 10 meters what you see. And I can assure you from testing both here in the US and in Norway, it is amazing how unprepared people are if they are not focusing and looking for it. If nobody has told them, look up and look for something, you can sneak all over them into very close vicinity and distance from them, and you basically hang in there, take in all the details, including IDs. You can see who it is, and then get off again. Yeah, this is just actually a slide that sums up a little bit about mission objectives and what we call the typical tasks. They are actually self-explanatory, but it shows the versatility and the flexibility of the systems. How many types of missions we can do this for. One thing is to be somewhere downrange and somebody's shooting at you. Instead of sending a guy in harm's way, you send out this one up on the ridge a mile away or half a mile away, and you check out, are there only 2 wannabes up there, or is it a full-fledged platoon hiding there ready with heavy weapons? Even today we have issues 10 minutes before we enter into a compound. What's behind that 10-foot dirt wall there? Have they changed the guard posture or have they not? Send it in, have a quick look, and then you can move on. That is a couple of examples of the relevance of this system. Yeah, oh sorry, let's go back one. There we go. This isn't anything more than showing a little bit about the flexibility of the system and the fact that it can be used both by military and law enforcement. Urban scenarios, yes, primarily perhaps for law enforcement, but also relevant for military. And for those who are wondering why we took the picture up right there, yes, it is from the Super Bowl. And you see a couple of more field-like pictures in the lower area there. We are involved in a lot of various types of training with units. We have been with the Army's large T&E activities over the last couple of years, AEWE, NIE, etc., and we will continue, of course, to do that and to support the Army. As I mentioned, we launched, or we did it actually a year ago, a night capability. Does it change night in today? No. Does it give you a certain capability? Yes. It looks just like this one, same form, different color. It's black, but the main thing are the sensors, of course, night sensors, thermal image camera, electro-optic camera with fusion technology. So you can basically mix and match with the filters, and you can try to get the best out of it. Does it give you and tell you the face of the guy? No, who it is. But it can tell you that there are 4 guys there, and they are moving in direction southwest, and they shouldn't be there. That is one of the things. You see some of the pictures there. It has proven to be a very valuable tool also during daytime operations when you don't see anything because of bushes, and you can send it out, and I call it a trigger. you see, okay, hotspots there, and you easily see these guys have 4 legs or 2 legs. What is it? And you can make a decision based on that. As you see from this slide now, there is a little bit of small text here, but what you see is what is called the Black Hornet 1 back in 2012. That was our breakthrough. The UK Army made a large acquisition, and they are the ones who've been using it operationally downrange now for several years. The present model is what we call the Black Hornet 2, what I've shown you here, which is all over the line, a lot of improvements over Black Hornet 1. And needless to say, behind those 2 nice pictures on the right-hand side there, where you see basically a Black Hornet 2 helicopter, and in the lower right corner, a Black Hornet 2 stretched helicopter, it just depicts that we are moving forward, of course, needless to say. We have put a lot of focus into training and simplicity. I talked about how simple this system is to operate. It is also related to the fact that in some countries, including my country, back in Norway, and also in the UK, the military aviation authorities, they have basically drawn a line in the sand. And they have said everything that is smaller than, slower than, lighter than, is hereby exempt from aviation regulations. And that means that you don't have to worry about all those, the whole barrage of regulations to that. In Norway, they have said everything that is less than 60 grams is deemed to be inherent safe. I.e., if this one crashes into a human being, there are nothing happening. Okay, you might get a scratch. If you crash into a helicopter or into an aircraft engine, nothing happens. All parts here are combustible, no steel parts, etc., etc. And when we think about that, together with the operational concept, which is easily accessible, lowest level, no calling up to higher headquarters and endless coordination, those 2 goes together. So you can really do that, and you can send it out. Of course, there are altitude limitations. When I talked about 12,000 feet, that is, of course, not the relevant altitude here. This one operates, as I said, from this up to a couple of 100 feet. If we go to 1,000 feet with this one, the sensors are not good enough to cover that. But even though it is a simple system to learn to fly, we have developed training tools. We have developed simulator, we have developed computer-based training, and of course all types of manuals. So when you have so limited time, it is important to have those in place. Normally we would say, we would ask for a 2-day course with the operators, and if somebody pushes me, like they always do, and they say, Arne, we don't have time for that, and I say, give me 1 day. And I can make you a reasonably good pilot to fly basic missions. If we get a full day and we are focused and we do a good job, we can do that. So simplicity for the operator is extremely important here. So what we have done now also is that we think we are able to meet some of the Army warfighting challenges on this level. We think it fits well into the existing US Army doctrine. We think we have some good options for future development of the doctrine. And especially this system adds up to survivability, lethality, especially lethality also, in addition to survivability, and also mobility when it comes to how we look into the future here. And needless to say, for those of you who have been, for those of you who it is relevant for, the Army is now moving forward with a program for soldier-borne sensors. And we think, of course, and we hope that we can be relevant to help the US Army with that program in developing further capabilities. My good friend Ole, and he is from Norway. He is the global VP of business development. He's ready to take you out around the corner here outside and do a short flying demo if there are anyone here who has an interest of that. So he will walk out there and fire up the system and give you just a short demo. But before we do that, I'm ready for questions, comments, and good suggestions.
Sir,
Thank you.
Sir, let me just first apologize. That video problem was totally on me and not the crew in the back.
I'm counting the beers.
Yes. So everyone else submitted a white paper to be part of the Innovators Corner. You actually did a demonstration. So I watched the demonstration, and I got the impression that the system is smart enough, or at least designed, where it won't fail, in the sense that if the conditions aren't correct, i.e. no GPS or too strong a winds, it won't take off. Is that correct?
Yes. A couple of things there. First of all, if it loses GPS connectivity, it will abort mission and go back again. If you, for some reason, loses the radio link connectivity, it will tell you, it will wait for a few seconds, then it will automatically climb 60 feet. If radio connectivity is re-established, you can continue the mission. If not, it will return to the operator. If the bird on its way back to the operator regains connectivity, then you can stop the bird, you can re-engage, and you can go another route, or you can try again a little bit higher up, i.e. there is a lot of flexibility for survival built into this bird. The third issue I would like to mention is there is also a lost bird function here, which is especially, I personally say, 90% relevant for training, because during live operations it might not be possible. But let's say we are on a training mission and 800 yards out there you crash in a tree. You will get direction and distance on your screen through the GPS and inertial navigation system, and you can start walking. And when you get close enough, there is both a small red light signal here in case of darkness, and there is a small sound signal also, so you can get beep, 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 beep for a couple of seconds. When you know that you are within 2-3 meters, you see that on the screen. So there is a lot of, this is not a throwaway sensor. It is a sensor you would like to have back. But let's say throwaway, it depends on the perspective. If you are high up in the army, throwaway means something else than when you are on the ground sometimes. So, but it has built in a lot of capabilities for getting the sensor back again.
Thank you. And one additional question for me. I understand the history of your program. You've overcome obstacles to innovation. One of them was the frequency management issue. You changed out the radio to meet DoD and Suncom's requirements. What other obstacles, for instance, cost pricing, are you going to be able to, kind of destroy that obstacle, that barrier to innovation?
Let's start just a few words about the frequency issue here. Originally, this was developed on a frequency slightly below 1 gigahertz. And it turned out back in 2012 that the frequency management authorities here in the US were not capable of allowing that, and it materialized to us because we saw an opportunity to help the troopers downrange in Afghanistan. So formally it was turned down by US Central Command and their relevant authorities. That led to a very good process with the Army's NSRDEC, and we got some RIF funding. So it was a true joint company, NSRDEC, Norwegian-US project, which has developed a new radio link on a different frequency, which is now approved by the relevant authorities. And that is an extremely important thing for us as a company, because it's a new piece of information, and now the official US management or those who can really sign off that sheet of paper has done it. So we are good to go on that one. Come general pricing. There are many things that can be said about pricing of capabilities. And one thing is, of course, the price of a few handmade prototypes in one part of, as a part of the development. We all know that that will have a very different pricing compared to large number as a part of a program of record. The same goes for us. The challenge sometimes is that the human brain seems to have an incredible memory for the first price. And you really have to beat them hard sometimes to tell them that, hey guys, this is not going to be the price in the future. I'm saying it with a little bit of a smile, but you know how it is. Come future, come large production, come large numbers, come total different price levels. But I have to be honest with you and say, sometimes I say, you won't get a capability perhaps which the troopers are looking for by running to Radio Shack and buying something for $500. When you buy something very cheap and you fly behind the two of those curtains, if you don't have GPS or autopilot, nothing happens. Yeah, so it is about some basics here concerning requirements, what you want to achieve, and what capabilities you want to build in to the squad or to the operator. This one can fly out to a couple of thousand yards. Think of the team, ladies and gentlemen, the squad, cruiser weapons. That's 1,200 yards, give or take, depending what weapon we're talking about. But that would be, for many of us, what we look upon, the area of interest for a squad, a team, and even a special operator sometimes also out there. So we need to have systems that takes us out there and gives us that capability we are looking for. I don't know if that answered.
Yes, sir, it did.
Yeah.
Any more questions?
Sir. I think, sir, we are well underway to develop Black Hornet 3, and I would be very grateful to have you come and visit our booth down here in a few minutes, and I will be happy to give you much more details about that in a different setting. Okay, they left again, so if anybody wants to see the bird flying, oh, yeah. Okay, yeah. I thank you for your time.
Thank you, sir.
Yeah, good to be here. And please go out and have a look at it. It is a mind-blowing product. Thank you.